say here. Now, so what I have said so far is, let's say you have yes, so we use concept and construct interchangeably. Okay, usually we concept is the idea that you are talking about. Construct is something that is going to be used in a scientific study. Okay, so concept is the idea, construct becomes the idea that is going to be used in a scientific manner. And then we use the third term, which is variable. Variable is nothing but an operationalized construct. That means you have created a measure for the construct, and now you have through this variable or through this measure, you have been able to assign a particular number to the construct. And that in the quantitative study, we use the term variable. So variable is nothing but an operationalized construct, right? Now, this is the concept that we were talking about, and this is the variable or the operationalized concept or the construct that we are going to do in the study, and this is the operationalized construct. Operationalized construct. Now I have shown this as broken line because I wanted to emphasize the point that this is intangible and this is abstract, right? Let us say this is this concept that we are talking about, the construct that we are talking about is intelligence. Okay, so this is the construct that we wanted to capture. Okay, and this is our measure. The solid line is the measurement, measured intelligence. Now, what happens in, especially in our discipline, is we show that there is a difference between these two lines. There is a difference between the actual construct and the measured construct, and this difference is denoted by what we call as the measurement error. That means the kind of measure that you are going to create and the kind of number you are going to capture through the measure that you have, there is going to be at least some difference between the actual construct and the measured construct, and we denote this idea as measurement error. So this is going to be a very important word that we are going to use repeatedly in structural equation modeling. This is called as measurement error. Now, the idea that we also work here is that no matter how hard you try, it is very difficult to make this zero. This measurement error will always be non-zero. There is going to be some measurement error that will continue to exist between the construct that you have and the actual measurement that you have for the construct. Now, why is that so? Why do we not claim that we can make the measurement error to be zero? We usually say that there is going to be some non-zero measurement error in our measurement. And the reason for this is why we say that no matter how hard we try, measurement error cannot be made zero. The reason is that we don't know the true construct. See, you can make something zero only when you know what is the ideal thing, only when you know what is the gold standard, right? So, what is my gold standard? And then what I am getting, what I am capturing, okay, how far my variable is from the actual true construct, right? Only if I know the gold standard can I compute this difference and check whether it is zero or non-zero. But the problem is what I have been trying to demonstrate or try to argue for last few minutes is that, well, we don't even know what the gold standard is. We don't know what intelligence is. It is just a concept. We don't know what would be the true standard for intelligence. We are just making some informed guesses. And therefore, to say that we have accurately captured intelligence, well, that is big leap of faith that we would be indulging in, and therefore we should not engage in that uh, a kind of uh, kind of science where we are saying that, well, even though I did not know what the true thing is, I am making a claim that I have measured it perfectly. So there will always be some measurement error, and therefore the fundamental equation that I would want you to remember, maybe write it down somewhere, is we always say in our in structural equation modeling, in measurement, we always say that there is x is equal to true plus measurement error, right? So what is x? X is my observed variable, right? So this is what I have captured from respondents, right? So I had, if I'm talking about motivation, I had a survey that I administered. I had a set of items that I administered to respondents, and then I collected some data, let's say on a scale of 1 to 5. Okay, so this becomes my observed data. This is my observed data. Now, there is also something that is called as true construct. Well, I tried to measure the construct, so that became my observed data. But there is something that through this observed, I wanted to capture the true construct, right? So my aim was to actually get to the true construct, to get to the actual motivation or to the actual intelligence uh, variable, right? So this is the true, and then there will always be a difference between observed and the true, which is called as the measurement error. There will always be some error of measurement. One, because we don't know the gold standard, and second is because the kind of items or the kind of instruments that we create, they have a lot of problems. So they are not accurate representations of the true construct. So we don't even know the true. And second is a lot of times our items or the surveys or the measures, they have some inherent problems in them, right? So there is this kind of a. Now, let me just take a detour